Hello, you guys. So after much deliberation, I finally decided that we are going to do chapter 11 as our final chapter. I don't think we'll have room for anything else because we're only going to be doing about one lesson a week so that you guys have plenty of time to ask questions and work through your homework and, all that good stuff. So this very possibly could be the last thing that we cover, and the reason why I'm choosing this over 10 or 12 is just because it's the most essential to what you'll need to know for my class, what you'll need to know for Algebra 2, and so on and so forth. So that's why we're going to do this one. Now, starting this chapter, we're going to be talking about these things called rational expressions. And rational expressions are basically expressions that have fractions in them. And I know that freaks everyone out because we don't tend to like fractions. But basically for this section, we're going to be following two steps. We are going to simplify the top and the bottom. And we're going to do that separately. Okay, so we're going to simplify the top, we're going to simplify the bottom, and then our second step will be to cancel anything they have in common. And then our very last thing that we'll do is do any kind of excluded values if they ask for it. Some of your problems on your homework will ask for excluded values, and sometimes they don't. So just always look for that first so that before you go and find the excluded values, you know whether or not you're going to need them. Okay, so let's kind of jump in. I'm going to warn you now, the first two are going to be a little bit rocky probably for you guys to kind of catch on to. But once we get to like the third question, I think it'll start making a little bit more sense for you. So what we're looking to do, again, is simplify top and bottom. The reason why this first one is a little rough because it doesn't really simplify on the top or on the bottom as it is. So I really just have this 21a squared over 7a cubed, and I can't simplify the top. I can't simplify the bottom, so I just have to leave it alone. And now we're just going to try to cancel anything that they have in common. And this one, it's a little bit harder to see that, but we're going to take it one step at a time. So we're going to start by canceling or dividing the regular numbers. I'm going to use dividing more for the regular numbers. So I can take 21 and divide it by 7. And when I do that, I'm going to get 3, and the 3 is going to stay on the top because that's where the bigger number was originally. Okay, if the 21 had been on the bottom, we would put the 3 on the bottom. But in this case, it was on top, so we're going to leave it there. Now, the second thing that we're going to do is we're going to look at the a's. So we have an a squared and an a cubed. We're going to think about the GCF. What do they have in common? Well, they both have at least 2 a's in them. Because remember, if we think about, let me see if, I'll write this down and then I'll have to erase it. If we talk about a squared, that's a times a. If I talk about a cubed, that's a times a times a. So they both have at least 2, right? And so I'm going to take 2 a's away from a squared, and in that case, it totally gets rid of it. When I take 2 a's away from a cubed, I'm left with just 1. So I'm going to have 1a left over on the bottom here because 3 minus 2 gives you 1. Let me get rid of, sorry guys, I'm still getting used to this new tool that I'm using. Let me get rid of this. So my final answer just becomes 3 over a. And that's it. That's your answer. Now, for these, they're asking us to state any excluded values. And that is every number that could possibly make our denominator equal to 0. And the way that we do that is we are going to take the original denominator, and when I say original denominator, I mean this thing right here, that is what gets set equal to 0 to find our excluded values. Okay, so we're going to set, sorry, I'm trying to find, let me do this. Oh no, that's not what I meant to do. I'm sorry, you guys. Like I said, I'm a hot mess still trying to learn this. Okay, so let me get rid of this. So that's my answer right here in this box. And then these are my excluded values. All right, so I have my excluded values. So I'm going to take the original denominator and set it equal to 0. So in this case, I'm taking 7a to the third and setting it equal to 0. And what that means is that I'm going to try to solve it for a. So in this case, I can divide both sides by 7, and 0 divided by 7 is still 0. So I get a cubed equals 0. And now I just kind of got to think about it. So what you're going to ask yourself is what number times itself 3 times will give you 0? Well, in that case, a would have to be 0. So your excluded value we typically write as an equal sign with a line through it because a cannot be 0. So this is your excluded value right there. Now in the future, I'm not going to write that much, and so we'll have a little bit more room to kind of work through this. But just to kind of give you the background of what we're doing, that's what's going on here. So that's how we find excluded values. So let's move on to the next one. So in this next problem, I'm going to change this color actually. So in this next problem, we're going to simplify on top and bottom first. So on the top, I have 18d squared. Unfortunately, that doesn't really simplify. It's just going to stay 18d squared. The reason why it doesn't simplify is because it's all one term, so I can't like take out a GCF or factor using 2 parentheses or anything like that. I just have to leave it alone. Now on the bottom, I do have some things that are being added together, so that'll kind of change this one. On the bottom, I have a 4d plus 8. And if I think about their GCF, it's not going to involve any variables, but their GCF between the 4 and the 8 would be the biggest number I can divide them both by, which is 4. So I'm going to put my GCF out front, and then in parentheses, I'm going to write whatever's left over once I divide by that GCF. So if I take 4d divided by 4, I'm going to be left with 1d. And then if I take 8 divided by 4, I'm going to get a plus 2. And now I want to try to simplify anything that they have in common. Well, looking at this thing, there isn't really a lot of options here. Okay, the d squared, let me highlight this. I really want to talk to you guys about this part. So the d squared and the d plus 2, I cannot do anything with. I can't cancel any d's here. I can't do anything to it. The reason why is because the d plus 2 on the bottom is in parentheses. In order to cancel out something in parentheses, it must be exactly the same as that. So if I had a d plus 2 in parentheses on top, then I could cancel. But I can't do that with the d and the d squared right now because the d is in parentheses. Okay, so I'll clarify a little bit more on that in a minute. But for now, the only real hope that I have is doing something with the 18 and the 4. No, I can't divide 18 by 4 like we did the 21 and 7, but I can at least divide them both by 2. So I'm going to do that. So I'm going to divide the 18 by 2, and I'm going to divide the 4 by 2. Okay, so I have 18 divided by 2, which is going to give me 9, and then I have a d squared left over. And then 4 divided by 2 is going to give me 2, and then we have a d plus 2. So this is actually my final answer. The only thing that I could really do is simplify on the bottom and then divide them both by 2. So that's my final answer for the actual answer portion. Now I'm going to find my excluded values. So for my excluded values, I'm going to take my original denominator and I am going to set it equal to 0. So I'm going to take the 4d plus 8 and set it equal to 0. Okay, so 4d plus 8 equals 0. I'm going to subtract the 8 over to the other side. Remember, I'm really just trying to get d by itself. That is solving this equation. So I get 4d, sorry, I don't know if you can hear all that background noise. I have my window open and I live near 31, so it's kind of noisy. Okay, so I have 4d equals negative 8 once I moved this 8 over to the other side. Now I'm going to divide both sides by 4. So I end up getting d, and we want it to not be equal to negative 8 divided by 4, which gives me negative 2. So that is my excluded value. Okay, so the answer is the 9d squared over 2d plus 2. The excluded value is d cannot be equal to negative 2. And the reason for that is in our domain, we can't include that number because if I plug it into my original denominator, I'm going to get 0. And you guys know we can't divide by 0. If you type something into your calculator and you divide it by 0, you are going to get an error message. We've talked about that sporadically throughout the year. Okay, so if you guys were able to hang on through those two, it's going to get better, I promise. Okay, so let's look at the next one because I think this is where it might start to click. So once again, our first step is to simplify on top and bottom. So we're going to simplify this top portion, which is 2n minus 3. Well, the 2n minus 3 is as simplified as it's going to get. I don't have a GCF that I can take and divide 2n and negative 3 by. So I'm just going to leave it alone. However, I can simplify 6n minus 9. They have a GCF, and their GCF is 3. So I'm going to put that out front. And remember, the GCF is just the biggest number we can divide both of those regular numbers by. In this case, we don't have any variables that we can take out. So I'm just going to divide them both by 3. So if I do 6n divided by 3, I get 2n. And negative 9 divided by 3 gives me negative 3. So this is where things start to get a little interesting. Because at this point, I'm starting to see that I have some things in common here. I have a 2n minus 3, and although it wasn't originally in parentheses, you can put those parentheses around it since it's your entire numerator. And I have a 2n minus 3 on the bottom. Because these are both in parentheses and they are exactly the same, including their signs, we can cancel them. So we can cancel out the 2n minus 3 on the top and the 2n minus 3 on the bottom. Okay, because they are exactly alike. So what that means is that we are going to be left with, if everything cancels on either the top or the bottom, if everything cancels out, we're left with an invisible 1, kind of as a placeholder. And on the bottom, the only thing that was left was a 3. So my final answer is 1 over 3, or 1/3. Okay, so that's my answer. Now, I'm going to go find my excluded values, which again, we have to go back to the original denominator, which I already have circled up here, right here, 6n minus 3. And I am going to set that equal to 0, and I'm going to solve it for n. So 6n minus 9, I said that differently, 6n minus 9 equals 0. So I'm going to add 9 to both sides. Because I'm trying to move everything away from the n so I can solve it. So I get 6n equals 9, and then I need to divide both sides by 6. So I get n equals 9 over 6, which I can divide them both by 3, and I get n equals 3 over 2 as my excluded value. And again, we're going to make that not equal. Okay, so then on this next problem, we're going to kind of practice those same things again. And I'm sorry, I know that this is getting really cluttered, but I don't really know what else to do with it right now. This is kind of my first time teaching notes on here. So in this next problem, once again, we're going to treat top and bottom separately. So on the top, this one is a lot like the last one we did. The 2x minus 8, we can simplify a little bit. We can take out a GCF. So I'm going to divide the 2x and the negative 8. I can divide them both by 2. So I have 2x divided by 2 gives me just an x. Negative 8 divided by 2 gives me a minus 4. Okay, so I simplified the top. Now I'm going to go and simplify the bottom. That's going to look a little bit different this time, because on the bottom, you guys will see, I have a trinomial. There's an x squared, which means I have to factor. And this is the basic factoring, so we do not have to do X method. I'm going to start by putting an X and an X in. And now I'm going to refresh your memory a little bit. So in factoring, remember that last term sign is what's really important here. That last term sign is going to determine my other signs. So if it's a negative, remember that means I need one of each sign in my parentheses. If it were positive, we'd have to look at the middle term sign to figure it out. Okay, so I need numbers that are going to multiply to 8, but subtract to give me 2. And so the only two numbers that work for that are 4 and 2, because 4 times 2 gives me 8, but 4 minus 2 gives me 2, that middle number that I'm looking for. So we're going to take the bigger number and we're going to put it with the middle term sign, which is a negative. So the 4 needs to go behind the negative, and the 2 is going to go with the plus. Now, if you have something that simplifies on top and bottom, typically, if you're noticing that things are almost right, but they don't quite cancel, always go back and check your signs, because usually something will cancel. Okay, so what we're looking at here is now that top and bottom are simplified, we can cancel out anything that they have in common. What they have in common in this one is the x minus 4s. So those are out. I can simplify that. However, what I can't do is I cannot simplify the 2 that's in green up there in the numerator with the 2 that's inside the parentheses on the bottom. Because remember, like I said, if you're going to cancel out anything with those parentheses, they have to be exactly the same. All right, so we're not going to mess with it. We're just going to leave it alone. So my simplified answer is going to be, let's do green. 2, which is left on the top, and on the bottom I have an x plus 2, and you could leave that in parentheses if you'd like. You don't have to though, since it's the only thing on the bottom now, but if you want to leave the parentheses in, it would not be counted wrong. All right, and then we have to find our excluded values. We're not going to do excluded values for everything in this chapter. It's really just for this first part. All right, so I have my excluded values. Remember, I have to take my original denominator and set it equal to 0. So I got to do the x squared minus 2x minus 8 equals 0. And we're going to factor it. Well, we already did that. Okay, we said that it was x plus 2 and x minus 4. And this is like one of the very last things that we talked about when we were together, is that if we have two pieces that are both set equal to 0, then we're just going to set both pieces equal to 0 separately. So we'll have x plus 2 equals 0 and x minus 4 equals 0. And I'm going to save a little bit of space. Remember, to solve x plus 2 equals 0, we're just going to subtract 2 from both sides. So we get x cannot be equal to negative 2. And over here we would have x cannot be equal to 4. So you have 2 excluded values here, but that's okay. All right, so negative 2 and 4. So when you type that into Math Excel or something, you'd probably have something that looks like this, and you could just separate them with commas. All right, so those are your excluded values. And your answer is what we have in the green box. All right, so we're gonna keep going. I'm not really sure how this is all gonna work because we're at like 20 minutes, but we're gonna keep trucking away and see. Hopefully this will upload. If not, then I guess I'll be doing this all over again. Anyway, so the next one, we're going to kind of do the same thing. We're going to do more factoring. So we're just going to jump right in and start simplifying the top. So on the top, I have a trinomial. I see an a squared. That's my key that I need to factor this thing. And so I'm going to be using 2 sets of parentheses since there is no number out front of the a squared. You do not have to worry about doing X method. We can just factor it like normal. So I'm going to plug in some a's. My signs are both going to be a negative because my last term is a plus and my middle term will determine the signs then, and the middle term is negative, so they're both going to be negatives. Now I need numbers that multiply to 2 but add up, and we're adding because of this sign right here, so they add up to 3. And the only numbers that do that are 2 and 1, because 2 times 1 gives me 2, but 2 plus 1 gives me 3. And since my signs are the same, it doesn't matter where I put what. Now I'm going to go and simplify the bottom a little bit. All right, so on the bottom, I have a 3a minus 3. I can divide them both by 3, so that's my GCF. So I have a 3. 3a divided by 3 gives me just an a, and then negative 3 divided by 3 gives me a negative 1. So now I can kind of see that I'm going to have some things that cancel here. All right, if I look, I've completed my first step. Now I'm going to cancel out anything that they have in common. They both have an a minus 1 in parentheses, so those are going to go away. The only thing left is going to be the sorry, I'm trying to figure out where I want to write this. I'm going to write it over here. A minus 2 over 3. So that is your answer. And now we're going to go find. Okay, so I kind of boxed that off a little bit. So my excluded values, I'm going to take my original denominator, the 3a minus 3, I'm going to set it equal to 0. So I'm going to add 3 to both sides to begin with. Divide both sides by 3. And we get a cannot be equal to 1. So that's my excluded value here. Okay, so I have my final answer in green. My excluded value is in red. Sorry, I didn't realize how Christmassy this looks. Okay. Next one, we're going to do factoring twice. Okay, so we're going to factor on top. Same type of factoring, just the basic factoring. I'm trying to conserve a little bit of space here. So we're going to have C and C. My last term is negative, so I'm going to have one of each sign. And I need numbers that multiply to 6, but subtract to give me an invisible 1 in front of the C. So my numbers that are going to work are 3 and 2, because 3 times 2 gives me 6, but 3 minus 2 gives me 1. And the bigger number needs to go with the middle term sign, which is negative. So the 3 goes here, and the 2 is going to go there. Now we're going to simplify and factor out on the bottom. Okay, so I have C and C again. My last term is positive, which means my signs are the same. Then my middle term is positive, so that means that they're both going to be pluses. And I'm looking for numbers that multiply to 6 but add up to give me 5. So again, 3 and 2 are going to work here, because 3 times 2 gives me 6, but 3 plus 2 gives me 5. And it doesn't matter where each one goes because they're the same sign. Now we're going to cancel out what they have in common. The only 2 that are exactly the same are the C plus 2's. So those are out. The C minus 3 and the C plus 3 are really, really close, but I cannot do anything at all to either one of those. I can't cancel out the C's, I can't cancel out the 3's. They have to stay exactly as they are because they are not exactly the same. So I'm going to leave my answer like this. Okay, so that's the final answer. Now we're going to go and find our excluded values. And again, since we already factored the bottom, this is going to be pretty easy, or at least pretty quick. So remember, it's my original denominator, set equal to 0. Oh, sorry, I turned off my pen. So I have c squared plus 5c plus 6 equals 0. And I'm going to factor it, which I already did, which is c plus 3, c plus 2 equals 0. And that means that I'm going to set each piece equal to 0. So I'll have c plus 3 equals 0, c plus 2 equals 0. So c cannot be equal to negative 3, and c cannot be equal to negative 2. So those two are my excluded values. Okay, we're almost there. Almost there. All right, so, whoa, sorry, I'm still getting used to this pen that I had ordered to go with my iPad, so I'm just all over the place. Okay, so I'm going to simplify on top and bottom in both of these. As you can see, they're going to be a little bit quicker just because they're not as long. We're not going to be doing anything too complicated, but these are both kind of a special case. So on the top of the next one, the 2x minus 5, there is nothing that I can do with this thing. I'm going to leave it alone. On the bottom, though, you'll notice these are really, really close to being the same. So I'm at least going to rewrite the bottom and take a look at what I'm dealing with here. So as you can see, they are almost nearly identical. They have the same numbers. However, their signs are opposite. So here's what we're going to do with this thing. It's a little weird. On the top, I'm not going to do anything. But on the bottom, if I divide everything by a negative, I'm going to get 2x minus 5, which would be awesome because then I can cancel. So I'm going to factor out a negative 1 on the bottom. And then I have a positive 2x minus 5. Oh, sorry, I really confused myself for a second because I'm like, why is the sign different? This should have been a minus. Okay, so whenever we divide by a negative, all it does is change our signs. Now we have something that can completely cancel. The 2x minus 5 and the 2x minus 5 here will go away. And basically what we're left with is an invisible 1 on top over a negative 1 on the bottom, and 1 divided by negative 1 is just negative 1. So believe it or not, negative 1 is my answer. Now if I want to find my excluded values, which as you guys know we need to do, I'm going to get rid of all that. Over here, I'm going to set my original denominator equal to 0. So we have this one right here. 5 minus 2x equals 0. I'm going to subtract the 5 over. I get negative 2x equals negative 5. And then I'm going to divide both sides by negative 2. So I get x equals negative 5 divided by negative 2. We're just going to leave it as 5 over 2. And we're going to put a line through that equal sign. Okay, so that's my excluded value. All right, last one. We're almost there. Sorry, guys. I know this is kind of running long today. I just want to make sure you guys have the basics. So this next one, the y squared minus 16. If you see a y squared, you know we're probably going to have to do some sort of factoring. And this one is a special case. We still don't have to do x method. I'm going to treat negative 16 as my last term. So since it's negative, I know I'm going to need one of each sign. And if you want to think about it this way, the way I would think about it is I have a y squared minus 16. So I'm looking for numbers that multiply to 16 but subtract to give me 0 because I don't have a y term. In that case, they'd have to be exactly the same, which means they're both going to be 4. Okay, and then on the bottom, I'm going to flip this thing around, and it would be negative y plus 4. So it's really close to being the same, but again, we have to do that little negative trip. trick like we did the last time. So I'm going to factor out a -1 on the bottom. Sorry, it's going to take a second. All right, so I'm going to have the same exact numbers, except for the signs are going to be different. Now I can cancel. They both have a y minus 4 in them. So I'm going to cancel the y minus 4s. And I'm left with y plus 4 over -1. Well, guys, if we divide something by -1, all it does is change our signs. So our final answer will be negative y minus 4. And that's our answer to that part. Now we're going to go back and find our excluded values. Let me kind of box this off. All right, so last part, excluded values, original denominator, which is 4 minus y equals 0. This is actually super fast. We can do it either way that you want. The quick way would be to add the y over and you get y equals 4. Or you can subtract the 4 over. You get negative y equals -4. Divide both sides by -1. And we end up getting y equals 4 that way. Or y cannot be equal to 4. Alright, so we made it. I know this video is a little bit long. Unfortunately, I think it would have been just as long, if not longer, if we were in person. So if you guys have any questions, make sure that you're being in contact with me. I'm going to post a picture of just these notes by themselves. And obviously there's this video. So if you need anything, please let me know. You do have an assignment. Make sure that you check the directions in this tab. And if you need anything, hopefully I'll be hearing from you soon. You guys take care.